to start in just a minute. This clock says 9:22. Mine says 9:24. We're somewhere in there, but we can start with a little prefix. I'm not sure if Maria brought this up at the beginning, because I arrived a few minutes late. I firmly agree with the rule of 2 feet. Did she talk about the rule of 2 feet? Yes? Did anybody not know what the rule of 2 feet was? Okay, so if this presentation, or if this talk, or if this thing that we're doing here is not what you thought it would be, and you end up like on your phone and kind of bored and whatever, and you really wish you'd gone to some other session, stand up and go to that other session. Because this is for you, and like I'm only going to be a little offended. I might cry a little bit later, but you should still do it. You should still get up and go to that other session and get the most out of your day, rather than sit here and like not get what you wanted. Sound good? All right. So this talk is called Hostile JavaScript, Attacking and Defending the Browser. And it's not the kind of thing that I have normally done. If you've met me before, if we've worked together, if you've seen me talk, I usually talk about monitoring JavaScript, or building maintainable front-end applications, or debugging errors and that sort of thing. And so security is a little bit of a new space for me. My name is Todd. I build things. I've built a lot of different things with companies over the years. I built a service called Track.js. Lately, I've been working on a thing called request metrics, which is kind of where some of the ideas for this are coming from. We're going to talk about 3 things today. First, we're going to talk about how do we go about attacking with JavaScript. If I get JavaScript in your page, what can I do with it? What kind of fun and terrible things could an attacker do with JavaScript? Second, we're going to look at vectors of how we could get JavaScript in your page. And then we're going to look at some ways to defend against those, so that we know how to protect our sites, how to protect our users, how to protect our applications. Cool? All right. To do that, I built a little sample website that we're going to use. And this is Todd's GeoCities fan site. So there's a lot of young people in the audience. Who here had a GeoCities page? Yes. This is where I cut my teeth on the web. This is modeled after one of the first websites I built, using one of the original backdrop patterns, a super pixelated blue brick background. And we always use the most obnoxious fonts in the most obnoxious colors, because why not? Unfortunately, the marquee tag no longer works. Otherwise, this thing would be marqueeing across the site. Like all GeoCities sites, they were constantly under construction. They were never finished. And we filled them with obnoxious things, like GIFs of dancing babies and stuff like that. Of course, there was analytics, even back then, in the form of these site counters. The great thing about those site counters is that they actually didn't have to work correctly, and you could start them at whatever number you wanted. And so if you wanted your site to look like it was really, really popular, you could just start your counter at 1 billion, and it would be great. And of course, there were ads. These are some early ads from the internet. Pizza Hut was one of like the pioneers of internet advertising. In order to build this site, I needed a little bit of JavaScript. So I had some JavaScript that I brought in, some of my own stuff that I would host on my GeoCities domain. I'd bring in jQuery, because sometimes I still like jQuery. I'd have my counter JavaScript, counters.js, and some auto bid advertising thing to get some money from Pizza Hut. And this site is super popular. So many people hit this. I thought, hey, I should try and monetize this. So I got some marketing people to help me. And so marketing immediately, who's in marketing? Anybody here in marketing? Internet marketing? Okay, good. I don't have to like tame that down. All right, so marketers did what marketers do, and they installed Google Tag Manager, which is their way of basically installing a backdoor to install whatever JavaScript they want on my website without having to ask my permission. And so that's exactly what they did. They threw a couple more ads on there because we needed to boost some advertising revenue. And my counter didn't have the right font for what they wanted, so they threw a couple more visitor counters on there. And once they were done, I now had this extra JavaScript that was also running on my page. I had a Google Tag Manager script. I had a double click, a couple other trackers, some other cool stuff on there. If you'd like to check out this website, this is live. I bought geocities.website. and I host this site on there. So if you want to check that out, we're going to use it again later So if you have internet access and you like scanning QR codes, this is a QR code for you. On it, there's also a little form where you can say what your favorite thing about the internet was. Okay.
Is that a safe QR code?
Yeah, I'm not. It's not rickrolling you. I did at one point print a bunch of restickable stickers with QR codes that just drop you to the rickroll thing. You know, to slap on menus and stuff at restaurants. Anyway, let's move on. Let's talk about how do we go about attacking this page or a page like it. What are some ways that some malicious actor could take advantage of GeoCities' website for their own nefarious gains? The first and most obvious and most widely used attack is by using the resources of your users to make money off of my stuff for their own purposes. And some people do that with more advertising. They'll come in and just slap more ads into the page, but they get the money for those ads. Some more creative people use things like CoinImp. CoinImp is a cryptocurrency implementation that can be mined with JavaScript. So we put this JavaScript in your page, and now we're using the power of all of your web browsers to mine cryptocurrency for me, which is great. Because then I get all of this. It's like the SETI. You remember the SETI program that you'd install the little SETI thing and it would use your SETI at home, and it'd use everybody's processing power to search for aliens. Well, this is using everybody's processing power to mine cryptocurrency for me, which I think is great. Now, this is a real thing. This isn't just some weird thing I made up. This was on the Supreme Court of the United States for about 3 or 4 months, because this thing snuck in through an accessibility library that was being required to be on a bunch of government pages. And so if you visited the Supreme Court pages during that time, you mined cryptocurrency for some unknown attacker. Once all this is done, my page looks like this. So I have a couple more ads on there. It's only slightly more intrusive. But the real problem is that your phone heats up super hot from all the cryptocurrency mining happening when this is going on. And we lost the babies behind the ads, which was really the whole reason you went to the page, right? Yeah. All right, the second way that we can attack users is by compromising them, getting them to give us information that they wouldn't want us to have. One way is we could just pop a login window that looks like it would belong on the page. This is obviously what a login window on GeoCities would look like. And so I get them to type in a username and password. Now, they might not know what their username and password is, and so they just try what the username and password that they use for everything is. And then I have the username and password that they use for everything. And I can try it on their Gmail, I can try it on their Dropbox, I can try it on anything else because I have the thing that they would use. Or I can trick them to log into another service by just rendering a piece of clever UI that says, hey, sign up with GitHub, sign up with Google, whatever, and then pop a window that looks like you're logging into Google, but the domain is slightly different. And now I have their Google credentials. So that's cool. That happens a lot. They're also really boring exploits. I like to think about better, more interesting exploits, which is the third part, around stealing data. Stealing data happens with 2 major patterns. First, monkey patching and keylogging. How many people know what monkey patching is? All right, cool. This will be less shocking. Sometimes I've given this talk at a security group before who don't know a whole lot about JavaScript, and I describe that this can be done, and the color leaves their face. So in this is an example of monkey patching. We're going to monkey patch the fetch function. So fetch is one of the core JavaScript functions that's available to us to send network requests. So I'm going to take a copy of that fetch function. I'm going to call it ofetch. And then I'm going to redefine what fetch is. I'm just going to overwrite the base fetch function with my own thing. That whenever it fires, it's actually going to send a copy of whatever you were trying to send out to x0x0day.br/clone and send a copy of the data that you were trying to send to my own endpoint, and then call through the original so that you don't think anything weird is happening.
Kind of a man in the middle.
Yeah, kind of. It's a man in the middle, but it's existing in the browser, so it's not like really leaving the network. So you think your service is doing something fun and cool, like posting a JSON payload with the user's name to your API, But I've kind of backdoored that, and I'm making a copy of that to my own clone endpoint. In which case, any piece of data that you send, regardless of if it's sensitive, not sensitive, whatever, I'm just taking a copy of it. And then I can sift through that data later to find cool things like credit card numbers and social security numbers and usernames and passwords and stuff like that. Another common way to do this is with a keylogger, which is just really simple. Hey, we listen for the key up event at the top level of the document. And whenever the user presses a key, we post that key out to my own endpoint. Now, this would obviously be super chatty and not performant at all. This is an example. But this is the kind of thing that you could make a copy of every single key the user is typing. So they're going into a credit card form and typing in their credit card number as 424242424242, which is one of Stripe's test credit cards if you do any of that sort of work. And sends a copy of that off to my keys endpoint. Now, this is not theoretical. How many people here are aware of MageCart? MageCart is one of those fun like marketing brand names given to a class of exploits. We don't know if MageCart is one organization or several organizations, but somewhere along the line, some security agency decided that we need to give this thing a name and we need to give this thing a logo, and they won. But essentially, MageCart is this collective that has installed keyloggers on thousands and thousands and thousands of e-commerce sites around the world and captured these keystrokes off. When they've infected a site with MageCart, they just listen for months and months and months. Because as soon as they actually go and take those credit card numbers and charge them, the credit card companies are in on it. They're like, hey, here's the common merchant that all of these people went through, and they shut it down. But in that time, they're able to capture millions and millions of dollars. This has affected British Airways. This has affected Ticketmaster. This has affected the British government. This has affected so many sites. Since 2015, over 70,000 stores on the internet have been cleaned of MageCart. Many more probably have it on there that we haven't detected yet. This is still an active exploit that is still running. And this is such a big deal that the credit card companies, as of 2025, have specific rulings around MageCart. So essentially, on your credit card checkout form, if you host it yourself, you either have to have no JavaScript on that form, or you need to be able to produce at any time a complete audit of all the JavaScript that runs on that form. This is all in order to prevent MageCart, because it has cost the credit card company so much money. One other really interesting attack is an active attack. Now, all of them that I've talked about so far are just passive. They listen, they capture volumes of data from your users, and then they look to see what's interesting later. But we could also use JavaScript to actively attack somebody. If you are a high-value site or a high-value person, I can use JavaScript on your page to receive remote commands. So I can essentially session jack your user, and make calls to your API as them and copy the data out. So if I'm trying to attack the CEO of a bank or something like that, and I can use a bit of JavaScript to do that, I can make fetch calls to your API to have them send emails or gather financial records or whatever their session would have authorized them to do. This is not theoretical either. There is an open source project called Beef that is a security researcher tool. It is not an attacker tool, although it could be used as such, that allows you to send these sort of commands through to an exploited client, which is kind of terrifying. But this only works if we get JavaScript into your page, if we can get JavaScript into your page. So let's talk about ways that we can get JavaScript into your page. The first and most boring way, but I need to cover it, is common server exploits. So any exploit that would affect your platform can put JavaScript to be hosted by your platform. So if you are on PHP, you need to make sure you have all the PHP security holes patched. If I get access to your Linux server or your Windows server, I can put all kinds of fun JavaScript on there. More interesting is cross-site scripting. Is everybody aware of cross-site scripting? Yes? We've been dealing with annoying people going to our forums and putting this bit of text into all of our forums for years and years and years to make sure that people don't do this. And unfortunately, sometimes this still works, and these things sort of sneak in. As long as the security organization OWASP has been keeping a top 10 list of exploits, cross-site scripting has been on that top 10 list of exploits. And it still is today. It will be next year. It will be the year after. This is an ongoing problem, is we need ways to protect our sites from getting these sort of things. Because when a real attacker comes in, they're not just putting this in. They're not just putting this script tag with an annoying alert box. They're putting a script tag that loads one of those malicious scripts, that loads a keylogger, that loads beef, that loads something like that. More recently, we've started seeing supply chain attacks. Has anybody heard of a supply chain attack? Yeah, a few people, good. So a supply chain attack is where we're not trying to attack you at runtime. We're trying to attack you at build time. So when you start a new project, let's say you're starting a new React project, and you go npm install React. And now like 100,000 lines of code have just been installed onto your machine. How many people go through and do a code review on that 100,000 lines of code to make sure that it's doing what you thought it was doing?
Every time.
Yeah. Yeah, totally, every time. We're all responsible developers, and we are totally going to take 6 months to do that thorough code review before proceeding to hello world. Yeah. No, of course not. We have a problem. We see this thing. We type install. Here's an example. This particular thing, if you're building an app with Ionic, and you wanted to install some icon package to it, you see this fun package out on NPM that does exactly what you think it does. Use npm install, and great, off and running. Now you have a bunch of icons in your Ionic package. Unfortunately, this was part of something called icon burst, which was a series of typo squatting packages on npm that really did give you the thing you wanted. It really did give you an icon pack for Ionic. It also contained MageCart. All of these packages did that. Ajax libs, icon package, umbrellas, Ajax library, things that, like, as a developer, we would just type and be okay with and move on with our day, and we're not going to go bother doing a code review and try and find that this thing happens. Typo squatting is a big problem on NPM. We see people who put malicious packages out there, trying to get developers to do a subtle typo that they would never even notice because the package installs, a whole wall of text consumes the console, and you never go back and look that you misspelled the thing that you wanted to get. And that's kind of terrifying for how many times I've npm installed something and just moved on with my day. I wonder how many times I've done that. What's another way we could inject stuffing? Well, this probably isn't super common, but you could build a service that gets people to put JavaScript on their page. That'd be kind of interesting. I did that. I built a service that asked people to put a little bit of JavaScript on their page in order to figure out how things break. And lots of people did. People took my JavaScript and they put it on their page, and maybe they paid me, maybe they didn't. Maybe it wasn't right for them. But years and years later, my JavaScript is still on their page. As of about 6 months ago, the sun.co.uk was pulling in my JavaScript from my CDN. They'd never paid me. They'd done a trial at one point, but they'd never paid me. They just never bothered removing the script from the site. And thousands of other big sites across the internet download my JavaScript and then just don't care.
You're not a billionaire today.
Well, I don't charge them anything. I should maybe mine some cryptocurrency, but you know. But that's not really a vector because all those people trusted that I'm a good actor and there's a bunch of legal stuff to enforce that I'm not going to do that sort of thing, and I would get in big trouble and I'd lose my source of income. But what happens if ownership changes? Not necessarily for my thing, but what if you depend on some open source package? What happens if you depend on some CDN? That you don't pay them, they're just a free thing. And then, the person who's burnt out in their basement because they maintain it in their spare time, ends up selling it to somebody else because somebody offered them $1,000 to take over. And that somebody happens to be a Russian group that wants to put MageCart everywhere. When you point at JavaScript at some third party that you don't control, you don't know. That they can change it at any time. Even if the good actor that you thought you were interacting with, that can change over time. And so the lesson is, control the scripts if you possibly can. Don't just point at some third-party CDN and trust that they're going to be a good actor in the future. Host them yourself, point at a stable version, something like that. The only way that a script that you would point at that from a good actor, for that really to be dangerous, would be if the nature of that script had a few characteristics. If the script itself was dynamic and it could like receive commands on what it was supposed to do, and if it allowed users to connect to it anonymously, and it allowed things to be a remote control, then even if the service was a good actor, it could still be potentially dangerous. Unfortunately, I built something like that called Remote.js, which was a little side project I did several years ago. And it was just this free thing that we built of like, hey, what if we could have all of the debugging capabilities of Track.js, but real time? Like, we wanted to connect to like some hard to debug device, like a set-top box that ran some version of Chrome, but you can't like connect a debugger to it, but it performed weird in some situation. So what if we could write JavaScript to have like this remote connection, like a remote Firebug connection to some other thing, with all of the same stuff of Track.js, but interactive? Well, we built that, and people used it in weird ways. I want to show you an example of what that does, because I put Remote.js on GeoCities website. So pop open GeoCities website. We're going to do a live exploit demonstration. Pop open, it's not really dangerous. I could only steal data that you put into GeoCities website. So don't type your credit card number into GeoCities website, okay?
I trust you.
So go out there and there's a big text box. Type into it your favorite thing about the old internet. And then we're going to do a little demo. So here I am. This is Remote.js. This is what Remote.js looks like. And Remote.js lists off everybody who is connected right now to GeoCities website. This was meant as a live debugger. So right now, there are a whole bunch of people connected to GeoCities website who've done something. So let's connect to one of them. So here's somebody with Chrome 112 on Android. Let's take a picture of what their screen looks like right now.
I'm sorry you were blocked.
This is what their version of the website looks like. Let's see what they typed in. They didn't type in anything. This is why I want people to type something in. Let's find somebody else. I want to find who I'm connected to. Songs that would pop you. Okay, that's cool. Who was that? Hi. So this is like a real-time connection. So I saw you type 53 characters into this and click the submit button. If I wanted to find out more, like I took a picture of your screen, I could figure out, say, what your navigator user agent was, and I can get that string to come back. Or I could say, I could fire an alert to you. This is like a fully interactive remote debugging session over the internet, which I thought was really cool. It's a really cool piece of like demonstration tech. Unfortunately, people didn't understand how this works, and they didn't understand that it's like totally anonymous. All I needed to know was like the key that was on the website to connect to the session, and if anybody who looked at the source code of the page could find out what the key was. And so people went and installed this and deployed it on sites, like healthcare sites. Like there is a Brazilian healthcare site that will not take us off their page, and I can connect to it, and I can see people interacting with healthcare records. And it's terrifying. People do not look at what they're putting on their pages, and they've installed this exploit. Now, this is niche enough that, other than you all and the other people I've showed this little demo to, there's probably not a lot of people in the world that know about this particular exploit. But somebody could build this. This wasn't like, patentable, like top secret technology. This was something that we threw together in a weekend to like see if this, was a proof of concept. The collective idea here is that people have no idea what JavaScript is on their page. Once a site has hit production, hit any level of scale, like there's a team behind it, there's marketers behind it, you've thrown tons of stuff onto the page over the years. Stuff has come in through NPM. You've thrown random scripts on the page to solve a bug. Your marketing team has thrown in a bunch of stuff through Google Tag Manager to track every facet of the user experience. And we have no idea what JavaScript is actually there right now, which is kind of scary. So let's talk about how we can fix that, how we can defend against it. Well, I always like to start with the boring rule-based stuff first. And so the first boring rule-based thing is to review your dependencies, which is something you're not going to do. I'm not going to do it either. It feels like the right thing to do, but it's unachievable without like more tools to like do scanning. Yeah.
I was going to say, all best tools to scan automatically.
Yep. Yep. You can scan for them. It's a bit of a race condition where the scanners will find exploits, and then the exploits that are really clever will outwit the scanners, and back and forth and back and forth. There's a couple of like obfuscation libraries that can hide MageCart really, really well. One of the things that this kind of comes around at is this concept of software bill of materials, which is a new concept coming around in the security space where we should be able to produce this list of here's all of the software vendors that went into this thing. But this is still kind of like a passive approach, or it's a checklist approach. I'm going through and I'm producing this list of things that these are the things I think I put in the site, but stuff happens in production that is rarely up to date. A really great way to solve this is a concept called content security policy. How many people have heard of content security policy, or CSP? Cool, this is great. So this has been around for like 8, 9 years. It's a set of rules that we can attach to an HTTP header to define what JavaScript and what kinds of domains will be okay connecting to. So that we can do things like saying, here's the places that I trust to load JavaScript from, and here's the places I trust to send my data to. Because you need it on both sides. The JavaScript could be from a safe domain, because it's a supply chain attack, but send to somewhere scary. And so content security policy can protect on both. The theory of content security policy is that this is what a policy would look like. It's saying, I only trust my website. If I load anything from anywhere other than my website, don't run it. Unfortunately, CSP in practice looks much more like this for most sites. Is you start with that, but then you also need Google Tag Manager. And then you also need tracking pixels. And then you also need the CDN. And you need 21 more other things. And maybe you want to load scripts from Track.js. And oh, I want to load images from everywhere. And then every day, somebody in the organizations needs something else. Because if it's not in this list, the site's broken. And so this turns into a process and administrative nightmare. And because of that, it is not super well adopted. If you are in a high security space, if you are a bank, if you are a government, if you are military, if you are something like that, you should use CSP. Unfortunately, you probably won't because of those overhead problems. If you do, there's a really cool tool by a guy named Scott Helm called Report URI, which is a way to help you build and manage those policies, and then they receive all the reports and help you do that sort of stuff. Unfortunately, less than 14% of pages, less than 10% of domains have a CSP policy on them. And this is a technology that is fully supported and been around for like 8 years. It's just not adopted because it's too hard, because it gets in the way of actually delivering our websites with how the modern internet works. Another way to protect yourself is with a concept called subresource integrity. So if you're too lazy or unable to self-host your own JavaScript, and you need to point at some remote CDN, how do you protect yourself that that CDN or that third party isn't going to change the JavaScript out from under you? This is an attempt to solve that. So you load your script file from example.com, and you include this integrity thing, which is a hash of the contents of that script. And when the browser downloads it, it's going to run that same algorithm on the script and match the integrity together. And if it doesn't match, it doesn't run the script, which is great. It prevents those sort of things from changing. The thing to note is that it requires the CORS headers. It requires cross-origin resource sharing headers, which is why you have to also decorate it with this cross-origin anonymous flag. And if anybody has been in the business of managing and debugging production websites, I built this handy flowchart for how problems typically go. Help, my website is broken. Is it DNS? No, it's cores. So unfortunately, requiring cores makes this another troublesome thing. Is if cores headers stop working, all of your scripts break, and now the page doesn't do anything at all. So the situation as it is right now sucks, and I don't think as an industry we have a good set of solutions for it. We have these technologies that should, in theory, solve these problems, but they're really hard to use and they break the website a lot of the time. And so in that balance of like security versus like accessibility, like the ability for people to actually do their work, right now the security tools totally blow that equation out of the water, and so we don't use them. So I've been thinking about a different way to approach this. And so I've been thinking about, here's my website. Rather than putting like CSP headers on this thing and building a bunch of process in place and making sure my third parties don't change stuff, what if I just tried to monitor the JavaScript with JavaScript? What if I just tried to put a little bit more JavaScript, and the point of that JavaScript is to look at the other JavaScript? Yo, dog, we heard you like JavaScript, so we got some JavaScript to go into your JavaScript to help you JavaScript. This is an old meme for the kids in the room. Okay, so with this is the idea. So we have this JavaScript that we put in place, and here's the JavaScript that I loaded on the page. And what this new piece of JavaScript would do, and there's the JavaScript that my marketers wanted to put on the page. And what my new JavaScript would do is it could run an audit of like, scrape a bunch of information about what JavaScript is on the page and give me this listing. Here's all the JavaScript and where it came from. And maybe how it got on the page. So things like, these things were loaded via script tags. But these things were loaded via a call to document write, or so they came in from a tag manager. And so I can produce like a runtime list of here's the JavaScript that's running. And then I can also do the same thing and use JavaScript to monitor like where does data go? Like when data leaves the page, where is it going and what kind of data is it? So if something on the page starts copying keys, posting keystrokes out to some third party, I could look at that data. I could say, hey, here's an AJAX request going off. I can look at the performance of it. I could also look at the payload as it's leaving and look for common words like name and email. Or I could run a regular expression and look for a credit card number and see, here's the places that are getting data. Now this doesn't exist. This doesn't exist. This is a mock-up. This is an idea that I built. It's just a picture. But like, what if I could build a report around third-party JavaScript? That like, it wouldn't stop things from happening. Stopping things from happening tilts that balance of like security and accessibility too far. I'm not trying to break the page in any way. I'm just trying to report on the page and say, here's the domains that you have trusted to load JavaScript. You trusted Google Tag Manager, which has loaded 6 files, and that domain is 10 years old. You've loaded Marketing Pixels. That domain's only 4 years old. You've loaded Cloudflare. That domain's been around for 8 years. But now you've started sending, or you've loaded some JavaScript from x0x0day.br, which is only 63 days old. And maybe it exists in some malware lists that I can look up. Like, that would be cool. That, like, in the matter of hours, I could see some attack JavaScript, like, has made it onto my page. Now, it still made it on my page, right? I didn't stop it from happening, but I could respond to it in hours instead of days or weeks or months or years. Now, we could do the same thing with, like, a data exfiltration report. Again, this is the same data that I've been capturing for, like, monitoring purposes for years, but I got to put, like, I'm thinking in terms of security, and security sometimes uses scary words like data exfiltration and vector, which are just like, ugh. They're not like, here's how you install something, and here's where your data goes. It's vector and exfiltration. Anyway, but we can do the same thing. We can look at, here's all the places the data has gone, and how much data has gone there, and what kinds of data. Like, this is stuff that, like, in theory, we've proved out like that this stuff works, and we started capturing some of this data, which I think is a really different approach to, rather than putting in these hard rules that like that use these hard security rules to stop us from getting our work done for the sake of protection, what if we can be a little bit more active and fluid? Yeah.
A quick question on, you mentioned about the monkey patching that actually can data do that.
Yeah.
Can you have two scripts on the same page doing?
Yeah, you can monkey patch and monkey patch and monkey patch. You can have layers. It's monkey patches all the way down. Well, so that's a really good point. So like, the order of execution matters. So one of the things that Track.js did is it monkey patches lots of different functions. And other libraries that do similar things would do the same thing. And lots of our customers would run us alongside other people. And so depending on the order that you were installed, I would monkey patch fetch, and then some New Relic would monkey patch fetch, and then Bugsnag would monkey patch fetch, and then we'd all do it. And as long as everybody did it correctly, it's fine. It's totally transparent, nobody knows. If somebody has a bug, it like manifests itself up or down that chain. For the purpose of security, that order really becomes important, because if the malicious JavaScript gets its monkey patch in first, it could potentially deny my monkey patch from working, and like then it'd be invisible to us. And so this is kind of like the downside of this whole approach. CSP is better because it exists outside of that JavaScript world. Inside the JavaScript world, JavaScript can mess with other JavaScript. So this isn't foolproof. This isn't like ironclad guaranteed security. This is, right now it's a crap show. We don't really know anything. This is better than nothing. With proper care and feeding, this could be pretty good. But there's risks. So this is what I have been thinking about. I don't have like a thing, like this isn't real. This is just something that I have been working on in my head for the past couple of months. At some point, it's going to end up in this thing that I work on called request metrics that tries to jam all that other stuff together. So those are the three things I wanted to talk about: attacking, injecting, and hopefully getting better at defending, and so that we're not in this weird space of web security where we pretend it's fine, but deep down we really all know that it's not. Thank you so much for coming. I'm happy to chat more.